So now that you're familiar with the basics of JavaScript, it's time to take a small break and take a look at some other skills that you also need to develop in order to become a great JavaScript programmer. So in this section, you will learn how to actually learn to code, how to think as a developer, how to debug your code in case you run into problems, and also how to set up a professional development environment on your own computer. And we're gonna start this section by configuring the VS Code editor to fit our needs a little bit better. And so that will then make coding a lot easier in the rest of the course. And once more, here on my desktop, I already have the starter files for this section. So go ahead and get yours from the GitHub repository as well, even though in this lecture we're not yet gonna need them really. But let's still open VS Code, because of course we're gonna need a VS Code window if we want to configure it. All right, now here on my desktop, of course I choose the developer skills folder, which is the folder for this section. And once again, we have an HTML file, which already has the script linked to it. And then here's also the script file, which has basically nothing. All I put here to get started is activating the strict mode. Because remember that from now on, we should use strict mode in all of the scripts. And so I left it here already so we don't forget it. But anyway, let's now start configuring VS Code, and we will start with a tool called Prettier. And Prettier is an opinionated code formatter, which means that it makes assumptions about how good code should look like. And so if we install it and use it, then this will make sure that your code is nicely formatted and also that it will look exactly the same as my code looks in the video. So that's going to make it easier for you to take this course. And also, of course, for you to write your own code in the future. So this tool is available as a VS Code extension. So let's click this extension button here. And then here all you have to do is to search Prettier. And it's going to be this first one. And I, of course, already have it installed. I just need to enable it. So I click here on Enable. But you will have to install it and then probably reload VS Code. So I enable it, and so now it is working. So install it on your end and reload the browser, and then come back here. Okay, so let's close the sidebar here again. And so installing this plugin was the first step. The second step is to now actually define Prettier as the default formatter of our code. So let's go here to Preferences, Settings, which should look something like this. And then here in the search bar, let's search for default formatter. So that's this one here you're looking for. And you see we have this huge list of available formatters. But the one that we are looking for is this esbnp.prettier VS Code. So this one should be here in case you successfully installed Prettier before. And so let's just click this here, and then we should be good to go. We just need to make sure that the format on save setting is also correctly set. So format on save. And we did this actually already at the beginning of the course. But in case you skipped that video for some reason, then just make sure that you actually tick this box here. All right. And so with that, Prettier should now actually be working. So let's just declare a variable down here and give it a couple of lines of space. And then simply x equal to something, and then give it a save. And you see that Prettier automatically did some changes to our code. So first of all, it removed all these blank lines that we had here. And it also transformed these single quotes into double quotes. Finally, it also added an empty line of code here at the end. Okay, so these may seem like small changes, but all of them added up throughout all the code can actually make a big difference. And again, Prettier is an opinionated code formatter. So opinionated means that they have a strong opinion, and then basically when we use the tool, we have to accept that opinion. And many people don't like that, but actually I believe it's a good thing. It makes it so that I don't have to take a decision on how the code should look like. For example, some people prefer to write the if-else statement without a space here, and other people like to have a space here. And let's just write something here. And so now, no matter what we do, Prettier will take that formatting decision away from us. So if I save this now, you see that it automatically inserted that space here, even if I don't like it. So if I remove it and save it again, it will be back. All right, but this makes it easier to make your code consistent and to make your code also consistent with other people's code. And in this case, my code that you can see here in the video. And so if we both use this tool, our code will look the same. Now, there are some things that we can configure. And for example, one thing that I don't like is the double quotes. I prefer to use the single quotes. But right now, Prettier will transform every single quotes to double quotes. So I add single quotes, give it a save, and you see now they turned to double quotes. And so some things we can actually configure in Prettier. So let me show that to you. So just Google Prettier, and probably the first option here will be this tool. So here we can go to Docs, and then probably here. So here we can do options. So configuring Prettier and then options. And probably the web page looks a bit different by the time you're watching the video, but just search for the options here. So let's take a look at some of the things that we can change. For example, the width of one line, or if Prettier should use tabs or spaces here, or if it should add semicolons or not. But what I'm interested here is the quotes. And so using this option, we can tell Prettier to use single quotes instead of double quotes. And so that's what I want. Now, how do we actually configure Prettier? Well, there are multiple ways, but the easiest one is to create a configuration file in the current project folder. So let's go back to the sidebar here. Then we create a new file, and this one is going to be called .Prettier and then RC. Okay, and now here we basically write this object, and it's not really an object because this is not JavaScript code. And so now we write single quote. And actually VS Code already gives us this option here. And then as I hit enter, actually we get this preset value. But I actually want to change it to true. Okay, and if I now give this one a save, and then also save this, then you see that it automatically changed my double quotes back to single quotes. Great. Now, another thing that Prettier does by default is something in arrow functions. So let me show that as well. And closing the sidebar here. So const, let's create a calc_h function again. Then we say birth year, and then we want to return 2037 minus the birth year. So just like we've been using. But now watch what happens when I give it a save. So you see that Prettier actually wrapped this single parameter here in parentheses. However, I actually don't like this. So when there's just one parameter, I like to see it without the parentheses. And so that's another thing that we can configure here. And so that one's called arrow parents. And so now we can choose between always and, well, some other options. So let's just search that here with Command F, arrow parents. So we can choose between always and avoid. And so I want avoid here. Okay. And so you can take a look at this entire list here if you want. And then you can change your own configuration to match your preferred coding style. Okay, and probably by now you don't have yet really a coding style, but it's good to know that you can change stuff that you don't like or that you don't want to see. So for me, this is the two things that I always change, and as necessary, I keep adding more stuff from time to time. So let's close it, give it a save to see if this change is now reflected here. And yeah, so as I saved it again, the parentheses here were gone. And remember that we enabled format on save. And so that's why all these formattings take effect whenever we save a file. All right. Now, if for some reason you cannot make this work, then don't worry. You can still progress in the course without having Prettier working. That's because this tool does, of course, not influence how the code itself works. It's just a visual tool that only changes how the code looks. Anyway, this was already a big step on making coding a little bit easier for us. But now I want to show you something else, which is to basically automate something very boring that we're doing all the time. And that is writing console.log. So whenever we want to log something, we have to write all of this console.log and do all this work. But in VS Code, we can configure snippets which can take that work away from us. So let me show you how. So we go here in the menu into this preferences folder or submenu, and then here we can define user snippets. So click on that, and then you can open one of these files, but the best thing to do is to just create a new global snippets file. So click that and then just give it a name, and it doesn't really matter. I'm just going to call it Jonas here. And so here we can define a couple of snippets. And remember that the snippet that we want to define is simply one that automatically writes console.log for us. And actually, there's already an example snippet down here, which basically does just that. So it's this here. And so let's just uncomment all of this. So again, with command /. And so this here is the name of the snippet. Then here we say that it works in JavaScript and in TypeScript. This is the command that will basically trigger the snippet. And here I like to use CL. So whenever we write CL in the code, it will then expand that to console.log. Then here is the code that will actually be written. And here, get rid of this second line. And then here, also get rid of all of this. Because I found that this is the best way to make this work. And it's not really important that you understand how this works. This is just a recipe that I want you to follow here, just to make our lives coding a little bit easier. So then give it a save. And once you head back to your script, and now write CL, which remember is this prefix, but you could have chosen anything else. But in my case, whenever I write now CL and then hit enter, it will give me console.log. And then all I need to do is to go back and then write whatever I want to log here. Now here we can also define this $1, which is the way it was before, and then this will place the cursor between the parentheses. But then I found that when you do that, the autocomplete in VS Code does no longer work. And so that's why I don't use that. So you see now the cursor is here, but then autocomplete does not work. And in this case, you can't really see that. But if this variable name was a little bit longer, XYZ ABC, and then XYZ, so you see that the autocompletion is not working. I would have to go down and go up again, and only then it would work. Okay, and so let's just remove that and call it a day. Okay, so from now on, I will no longer manually type console.log. I will always just do this. Okay, and now to finish, let's just go maybe a little bit over my extensions that I have here, just to show you what I use. So let's remove that search text there. And so these first two are about HTML development, and I'm going to show them to you in the next section. Then these don't really matter. ESLint is a tool that we're gonna use later. Image preview is also good for HTML. Then Monokai Pro is the theme that I'm using, remember. Then of course Prettier. Then I have Settings Sync, which is very useful to synchronize settings between different VS Code installations. For example, if you have multiple computers or multiple accounts on your computer. And finally, one that I use all the time is to do highlight. So this allows me to highlight parts of a text. So for example, I can do something like this. So when I write bug in a comment, for example, then it gives me this nice red highlight. Or fix me is another one. So let me show you my settings here that will show how I do that. So that is preferences and settings. And then we need to go here into this icon. And again, by the time you're watching this, this might have changed. But what matters is that you need to open the settings in a JSON format. And so this shows all the settings that I have. And so here is how I defined these, these colored tags. So you need to install the to-do highlight extension. And then in your settings, you just write this kind of code to define different colored tags for different texts. Okay, so very useful one again. Yeah, I think that's enough for this video. This one was not really about coding or anything. It's just to set us up for the rest of the course, and also so that you start getting a feel for a little bit of the tooling that we have in the JavaScript ecosystem. All right, and actually in the next lecture, we will continue doing that. So I see you there in a second. Up until now, whenever we changed our code and then wanted to see the effect of the code in the browser, we saved the code and then manually reloaded the browser. But there is a much better way. So instead, we can make the page reload automatically whenever we change our code in the editor. So let's now learn how. So in the real world, no professional developer reloads their browsers manually like we have been doing. So everyone uses some kind of tool to do that. So to make our life easier as we go through this course, we will now also install such a development tool, which is called Live Server. And we can actually use Live Server in two different ways. First, we can install a VS Code extension, or second, we can use a bit of a more professional workflow using Node.js and a so-called npm package. And let's actually start with the easier approach, which is to simply install the Live Server extension here on VS Code. So that's Live Server, and it's this one here. So just click install as always. And then as we close this, you will see that down here we have this Go Live button, right? And so let's try to log something to the console here now. Or actually, let's try to click this button here first. So you see it says starting, and now it opened up a new browser tab on this address here. So this URL. Okay, then here we click on inspect just to open up the developer console. Let's increase it a little bit. And you see that right now we have no output here at all. And that's because we are not logging anything here in this script, right? And so now let's try to actually change the file. So let's just call the calc_h function here. And now watch what happens as I simply save this file now. So I hit Command S, and you see that here on the other side, the output automatically appeared without me having to reload the browser, right? And if I try some other value, give it a save again, then you see that it updated here again. And so that is the Live Server extension doing its work. Okay, but let's take it back here and actually close this window, because this was only the first way of using Live Server. So as I said before, there is like a more professional way of running live server, which is by using something called Node.js, which is a JavaScript runtime that we can install on our computers. Now, if the extension that we just installed works just fine for you and you don't want to add any more complexity, then you can just skip the rest of this video and move on in the course. But I will actually use the second approach in the rest of the course, which is to first install Node.js and then use an npm package called liveserver there. But again, you can follow the rest of the course just as well by simply using the extension that we just installed. You don't need to install Node.js and the liveserver npm package. But if you're curious and want to see how the second approach works, then let's now quickly go ahead and install Node.js on our computers. So just Google Node.js here, and then it's probably this first result that you saw here. And Node.js is a way of running JavaScript outside of the browser, but also it's a way of running development tools, just like the live server that we want to install now. So go here to Downloads, and then you can use the LTS version for whatever platform that you're using. So Windows, Mac, Linux, just download whatever you need for your use case, then install it, and then come back to this video. Now, if for some reason you cannot do this, or if anything goes wrong, then don't worry. You can, of course, continue this course without using live server. So please don't get stuck on this video if you don't manage to install live server for some reason. Okay? Now, anyway, after you successfully installed Node.js, it will become available as a program in the so-called terminal. And let's use the VS Code built-in terminal. So VS Code has a terminal included, and to open it, we need to go to the menu bar and then New Terminal. Or we can also use this weird shortcut here, but I prefer to do it like this. So let's increase this a little bit, and then I will clear this terminal here by hitting Command or Control K, and that looks a little bit better. I can also increase this by hitting Command plus, and actually that increases the whole window. So that I don't want. So let's go back. But anyway, in case you're not familiar with the terminal, it is basically a way of giving a computer instructions. And we will learn more about the terminal later in the course. This is not the point to worry about the terminal. All I want you to do is to write node -v. Then hit return or enter, and then you should see some kind of number here. It doesn't matter what number, but as long as you see a number, it means that you successfully installed Node.js. So if you have this number here, then you can now write npm install liveserver -g. And in case you're on a Mac, you will probably need to sudo this command. So start the command with sudo and then npm install liveserver g. So again, it's not important that you understand what this does. Let me just in 10 seconds tell you that npm is the Node Package Manager, which is basically a program to download tools. Then here we say install, and then here we say that the tool we want to install is called liveserver, and -g means that it should be installed globally. And that will make the liveserver tool available everywhere on your computer. So if you're on a Mac, use sudo here before the command, but on Windows you don't need sudo. And it won't work even if you use sudo. Then hit enter, and if you're on a Mac, you now need to enter your password. And don't worry if you don't see anything there. That is on purpose. Just write it anyway, hit return, and then it should start doing something. So right now it is being installed, and I get some errors here, apparently, but I think they are not really important. Anyway, I already had liveserver installed anyway, and so these errors here, they should be no problem. So we can clear our console again by hitting Command or Control key, like this. And so that looks much better. And now all we need to do is to write live server and then hit return. So try that. And it worked. So it automatically opened up a tab in the browser. So probably in your predefined browser. And this browser tab is now connected to your current project folder. And so in the console here, you can see the folder, which is this one. So developer skills in this case. And so that's exactly the project folder that we are in right now. So whenever you run live server in some folder, that folder will then be opened in the browser. And whenever we open a folder in the browser, it will then open the index.html file by default. And that's why we always have an index.html file in any folder. Okay, so let's open up the console here. Then we get a small error, but as we reload the page, this error will disappear. Yeah, that's right. And so here, let's actually get rid of this. And here, let's log to the console the result of calc h, and then with some year, just so that we can now test this. So when I give it a save, watch what happens here on the right side in the browser. So I will not reload the browser, I will only hit Command S to save this file. And you see, it took like half a second, then the browser reloaded, and now we get the result here automatically. Also, you can see down here in the terminal that a change was detected, and so that's what triggered the reload. So any file that changes in this folder now will trigger a reload. So even if I change something in the HTML file, for example, if I save now, then see how it changed here as well right away. So let's put that back, close it, and actually we can even close this terminal. So if I close it and save it again, you see it reloaded again very quickly, and it's still working. So the terminal, it's still down there, it's just not visible. But we can always get it back by hitting New Terminal. And actually that's a new one, but then just click this menu here and go to the first one that we had, which says Node. Okay, and with this we established a real-world web development environment or workflow. And so now you can really start to feel like a real JavaScript developer, not one of the kind that has to manually reload their browser. So I hope that you find this as cool as I do. But in any way, we are now finished setting up our browser and also our development workflow. So basically, this part here of the section, so the editor setup, and so now we're ready to go a little bit into developer skills, because that's also an area that's important to develop for you as a new developer. And so the next couple of videos will be how to learn and how to solve problems. Now that you have a solid foundation of JavaScript, I want to talk a little bit about the actual process of learning how to code and give you some motivation. I think this is an important aspect of a course like this, but everyone else simply seems to overlook this topic for some reason. So let me share my advice on how you should learn to code as a complete beginner in this video. And to make this a bit more fun, I will start by telling you how to fail at learning how to code. And to do that, meet John. So John has been learning how to code for some time now, but he is failing miserably. He's just not going anywhere. I guess he's just not receiving the right advice. So let's see what John is doing wrong so that you can learn from his mistakes and learn how to code in no time. So the first mistake that John made was that he didn't have a clear goal at the beginning of his learning journey. He simply started by watching some courses and reading some tutorials, but he would just blindly copy the code without caring how it works. Even worse, sometimes he would just copy and paste code from tutorials or sites like Stack Overflow. While learning, he didn't reinforce what he was learning in the courses and tutorials by doing small challenges or taking notes. He also didn't practice coding outside of the courses, and he didn't come up with his own project ideas to improve his skills. Then, whenever he did code a bit, John would quickly become frustrated whenever his code was not perfectly clean or efficient. John also lost motivation pretty quickly because he thought he could never know enough. He could never know all there is to know. And this is a really big mistake. Also, he was just always learning in isolation without sharing his process. Finally, after finishing a couple of courses, he thought he was now a web developer and could start applying to jobs. But no one would take him because recruiters soon found out that he couldn't even build a simple app on his own. So that's a long list of mistakes, but it's not too late for John. We can fix all these mistakes, right? So let me show you how. So the first mistake is relatively easy to fix. What you need to do is to set a goal for yourself. Think about this and actually write it down on a paper or something. Make this goal specific, measurable, realistic, and time-based. For example, your goal might be, I want to become a front-end web developer within 1 year. From there, you can then develop a plan on how to get there. It also helps to know exactly why you are learning to code. For example, are you trying to switch careers? Or do you want to find a better job? Or are you just starting a new hobby? Whatever it is, it's important to be aware of the reason why you're doing this, because this will help you stay motivated when learning becomes more and more difficult. To stay motivated, it's also great to imagine a big project that you want to be able to build by the end of your learning journey. This has always helped me tremendously. With this project in mind, you just need to research the technologies that you need to learn, and then learn them one by one, step by step, in a calm way. Next up, instead of simply copying code from a course or tutorial, always make sure that you really understand the code that you're learning and typing into your editor. Don't move on if you don't understand. Also, always actually type code. Don't just copy and paste it from a tutorial or a site like Stack Overflow. This way, you're training your brain to remember the syntax later. Reinforcing is one of the most important learning techniques. It means that after you learn something new, like a new JavaScript feature or concept, you use it immediately to make it really stick in your brain. You can do this by taking notes and by challenging yourself with small coding exercises and challenges. For example, let's say you just watched the lecture about functions. So now you know what functions are and you saw some examples. But now, as a next step, you need to reinforce this knowledge by writing a function for your own personal environment. For example, you might need to calculate the average of your university grades, or you might need to convert recipe ingredients from ounces to grams while cooking. So just write a function that does this task for you and have some fun with it. Coming up with your own ideas like this and solving them will absolutely boost your confidence in your programming skills. And really take your time with this. There's absolutely no need to complete any course as fast as possible. Alright? Now, it's absolutely normal that in the beginning, it's hard to come up with your own challenges. That's why I included countless coding challenges in this course for you. You can also use a special challenge platform like codewars.com, where you can find thousands of coding challenges for different skill levels for free. I have actually solved some of Code Wars challenges in real life with some students, and I can tell you it's a ton of fun and really helpful. One of John's biggest mistakes was to not practice coding outside of the course environment. But practicing on your own is the single most important thing that you have to do. And I can't stress this enough, okay? Coding your own projects without any course guiding you is really not optional. If you just follow courses and don't code on your own, you will never ever be able to write programs on your own. So come up with your own project ideas, no matter how small or big, and just build them. Or you can copy parts of popular sites or applications. No matter what you do, really challenge yourself, make it difficult, and grow by overcoming obstacles. And I know it's scary to leave the comfortable environment of a course where you just have to follow the teacher, because you will fail and you will make mistakes and it will be difficult to code on your own. But getting out of our comfort zone is the only way we grow. So don't be stuck in tutorial hell, which is exactly the state of not being able to leave tutorials. And there is more about this whole journey at the end of this lecture. Now, when you practice, you should never become frustrated with the quality of your code. Do not get stuck by trying to write a perfect code, which is really clean or really efficient. So none of that matters in the beginning. You're still learning, so just write as much code as you can, no matter the quality. Really, clean and efficient code will come with time. Alright? It's just natural progress. Also, you can always come back and refactor and improve code later if you want to. Another important piece of advice I can give you, and I actually give it to myself from time to time, is to embrace the fact that you will never know everything there is to know in web development. Web development is this huge field, and so it's completely normal and acceptable that you will never know everything about web development. So don't put too much weight on your shoulders and create too many expectations. So in fact, the best developers and teachers have no problem in admitting that they do not know everything, like the legendary Kyle Simpson, who admits that even after 20 years, it's still a struggle to make his code work and understand it the next day. So do not lose motivation if you feel the same way. Also, do not compare yourself to top developers who do know a lot more than you. Because of course they do. Many of them have been at this for over 10 years, or maybe even 20 years. But nobody was born an expert. And even experts are still learning all the time. Now, here it's actually pretty important that you have a well-defined goal for yourself. Because if you do, you can just focus on what you need to learn in order to achieve that goal. Everything else is unnecessary. It's just noise. For example, if you don't need a backend in your app, then you don't need to learn Node.js or PHP. Okay? The next mistake that is hopefully easy to fix is to not learn in isolation. One great way to do that is to learn together with other people, no matter if in person or online. Whenever you learn something new, explain it to them, because explaining things forces you to really understand them first, and repeating a concept will then really make it stick in your brain. That's why many people say that the best way of learning is to teach, and I actually share that opinion too. Another great technique that many people like is to share your goals publicly, for example on a social network, to make yourself accountable. You can also share your progress on social media to motivate yourself and others. For example, on Twitter, there are some popular hashtags that people use, like hashtag 100 days of code, hashtag codenewbie, and hashtag webdev. If you use these, you will get feedback and a boost of motivation from other people that are on the same journey of learning to code. It's a really nice and friendly community, at least on Twitter, which is what I know and use. So for sure, you should try it out. And finally, the absolute biggest mistake that John made was that after he went through a couple of web development courses, he thought that he was now a web developer ready to take a job. Now, this is probably the biggest misconception that people have. Just take a couple of courses and you're done. But no, that is just not how it works. So I'm sorry to bring you the bad news, but courses like this one can only take you so far. They will give you an amazing foundation, of course, but they are just the beginning of your journey. You need everything else that we just talked about in this lecture in order to become a successful web developer. So let's talk a little bit more about this and the journey of actually becoming a job-ready developer. So here is a very true graph that shows you how your confidence in your skills changes as you become more and more competent as a web developer. And this is useful because it allows us to plan a strategy for your learning journey. So when you start, you are in the everything is awesome phase. You are studying one or more courses or tutorials, understanding how the code works, and taking a lot of challenges, just like I mentioned earlier. Now, you're not really competent yet, but are starting to get confident and are pumped to keep going. So this is probably where you are right now and will be throughout this course or any other course that you take. But then, as you start practicing on your own, you reach the cliff of confusion. Here you realize that coding might be a lot harder than you thought when you no longer can just follow a course with a predefined path. So your confidence is going to start to drop a little bit, and you might realize you can't build anything meaningful on your own yet. But don't lose motivation here. Just keep writing lots and lots of code on your own, no matter how much time you need to spend fixing bugs and searching for a solution. It's all part of the journey, and it's still gonna be fun. Slowly, you will become better at writing code, so you will become more competent. But your confidence might drop even further because now you start to realize just how much more you will need to practice until you can build a real application on your own. You are now in the so-called pit of despair, but believe me, it's not as bad as it sounds. You might start to feel lost, but a great solution for this is to start learning with other people, like other beginners or even other developers who might mentor and help you along the way. To leave the pit of despair, you must keep challenging yourself. You cannot stop here, okay? So keep building bigger and bigger projects, run into lots of problems, and keep fixing them. You really need to have this mindset of fixing problems in order to become a web developer. It's what we do all day long, basically. At this point, it's also important to keep in mind that learning how to code is a really hard thing to do. So don't beat yourself up for finding it too difficult and for being stuck all the time. It is difficult indeed, but it's gonna be worth it. And trust me, we've all been in that place. And everyone who successfully works in the industry today just started out the same as you right now. So really, congratulations for even starting this path. That's already a great achievement in itself. Now you just need to continue building stuff. If you want to know about me personally, I learned to code by starting projects that were actually way too difficult for me at the time. But that made them real challenges that made me grow tremendously. For example, I tried and failed to build a football simulation game with Visual Basic. Then I built a content management system in PHP with really bad quality code. But it worked, and I actually sold it to a client and made good money. I also accepted some client projects for websites that I didn't know how to deliver. But I figured it all out in the end, and it made me grow so much. And I'm sure that the same is gonna happen to you too. Anyway, back to the journey here. At a certain point, you will start to see the light. So at this point, you're getting quite good at writing code, and your confidence will finally start to grow again. You are now in the back to awesome phase. Now you can either start learning new technologies, or you can start rounding up your skill set with best coding practices and tools that you will need for jobs, for example, like version control, testing, task runners, etc. If your goal is to find a new job, you're probably starting to be ready to apply for jobs. You need many things for that, like a really good portfolio, but that is a topic for another day. Just be aware that even when you're working, you will never stop learning. So you are never really done learning how to code. Web development changes really fast, and so you will need to be constantly adapting to new technologies. All right, and that is basically the typical journey from start to job ready. Now, please don't be scared by what I just showed you. I'm telling you all these things not to scare you, but to prepare you, because I really want you to succeed on this path. And I want you to achieve real success, not like fake success. There are just too many people out there who will tell you that coding is easy and that you will magically become a web developer in 2 months if only you take their course. But this is simply not true. So I'm not going to sit here and tell you that coding is easy. It's not easy. But with the right attitude and the guidelines I showed you in this lecture, you can totally do it. And I mean that, because I've seen it happening time and time again. So many people have learned how to code from complete scratch, switched careers, found better jobs, and improved their lives dramatically. And I mean many of my students, and also many other people that I know personally. It's real, and you can achieve the same thing. Just keep going, keep coding, and keep building. In this lecture, we're going to talk about solving problems. Solving problems is one of the most important things in programming. So if your goal is to become a great programmer, you need to learn how to deal with problems effectively. So in this video, I will show you how to think as a developer by solving problems using a simple 4-step framework. And let's use our friend John again. So after some time, John can code now. He is almost job ready at this point, but he still needs to work on his problem-solving skills. And in programming, when we say solving problems, we mean a real problem that needs a real solution. For example, in an array of GPS coordinates, find the 2 closest points. And this problem is not straightforward, right? There are a lot of steps involved in solving this. And so we need a way to effectively solve problems like this one, or even way more complex ones. So problem solving does not mean to fix coding mistakes or bugs, alright? Anyway, whenever John encounters a problem that he needs to solve, he usually just jumps at the problem without much thinking. He also implements his solutions in an unstructured way without much of a logical approach. This makes him stressed out when things don't work right away. Another problem that John has is that he is too proud to research when he doesn't know how to come up with his own solution. So all of this is not effective at all. It makes John waste a lot of time. Now the first fix to this is to always stay calm and slow down and not just jump at a solution without having a plan. Also, when solving problems, you need to be in a mindset of taking a logical and rational approach. After all, programming is just logic, alright? Then, when you are in the right mindset, just use my 4-step framework to solve the problem at hand. And the first step of the framework is to make sure that you 100% understand the problem. Step back and take a high-level look at the big picture. And the most important part of this step is to ask the right questions in order to get a clear picture of the whole problem. And the best way of understanding this is probably to look at an example together here. So let's say you are working at some company on some project, and then your project manager comes and tells you, we need a function that reverses whatever we pass into it. And that's all you know about the problem. But do you understand it 100%? Well, probably not, right? I know that I don't. So let's ask the right questions to get there. First, we can ask, what does whatever actually mean in this context? So what should actually be reversed here? Well, and if we think about it, it only makes sense to reverse strings, numbers, and arrays. Objects don't have a well-defined order, so we can't reverse them. We're also not going to reverse like undefined or null or a boolean, right? Then, after we have that figured out, we can ask, what should we do if something else is passed in that is not a string, number, or array? How are we going to handle that? It's also relevant to ask, what exactly should be returned from the function? For example, should it always be a string, or should the type be the same as was passed in? Well, in this case, probably we should always just return the exact same type that was passed in. Also, we can start to ask more solution-oriented questions, like how to recognize whether the argument is a number, a string, or an array, or how to actually reverse a number, a string, and an array. So these are just some of the questions that we can ask here. I'm sure there are more, but this should already give us a way more clear picture of this problem. Now, right now, at the beginning of your journey, you will probably not yet know what the right questions actually are. But don't worry, this will come with time and practice, I promise. The next step is probably the most important one, which is the divide and conquer strategy. Divide and conquer means to break up the big problem into as many small problems as possible, because these small problems are then a lot easier to solve. And this also ties in with the previous step, because by dividing the problem into subproblems, you also take the big problem apart until you understand it exactly. So based on the previous step, if we wanted to break down this problem, we could define a couple of subproblems. First, we need to check if the argument is a number, a string, or an array. And this is, in fact, a small subproblem, right? So now we can just solve this one in isolation and then move on. The next subproblem is to implement reversing a number, then implement reversing a string, and then implement reversing an array, so that we are ready to deal whatever is passed into the function. Finally, we then also need, of course, to return the reversed value. So these are our subproblems, and they kind of look like a task list that we now need to go ahead and implement. And this is great, because it makes our work so much easier now. Now, sure, this example is a pretty simple problem, but this strategy works just as well for bigger and way more complex problems. In fact, divide and conquer is an essential method of problem solving that is also used a lot outside of programming. Anyway, with this, we have actually already covered the two most important steps of the framework. But now let's say that we actually do not know how to implement one of these subproblems. Well, in that case, we should not be afraid of doing as much research as we have to. Now, of course, we should always first try to implement a subproblem on our own using our own coding abilities. But if we're constantly hitting a wall and cannot move on, then we should waste no more time and just find out how it works using Google or a questions and answers website like Stack Overflow or the MDN JavaScript documentation. We will see how to use these in the next lecture when we're going to work together on a real problem. And actually, researching is a huge part of a programmer's job, as you will find out very soon. So you really should not be ashamed when you don't know enough to solve a certain problem. That's just completely normal. Now, in this case, some questions that we could Google are how to check if a value is a number or an array or a string in JavaScript. Or we could Google how to reverse a number or a string or an array in JavaScript. Okay? And again, we will do this in the next lecture on a real problem together. Finally, in case we are trying to solve bigger problems, we should put all the previous steps together and write some so-called pseudocode before writing the actual code. And pseudocode is simply an informal description of the actual code that we're going to write. So it's like code for humans to understand, not computers. For our example, the pseudocode might look something like this. So you see, we use some structures of a programming language, but this is clearly not JavaScript, right? And there are no real rules on how to write pseudocode either. You just write so that you understand it yourself or other people on your team. So in this example, we just start by naming the function as reverse, and then we basically pass in a value. Then we say that if the type of the value is not a string and not a number and also not an array, then simply return the value back. And that's because, as we defined previously, we only want this function to work for strings or for numbers or for arrays. And again, you can clearly see that this is not any valid JavaScript at all. But anyway, if the type of the value passed this initial test, then we say if the value is a string, then reverse the string. If the value is a number, then reverse the number. And if the value is an array, then simply reverse the array. And then at the end, we want to return the reversed value. Okay? So this is really more like a list of instructions that we now could go ahead and actually implement using the JavaScript language. Okay, and that's it. That's the 4 steps to solve any problem, no matter how big. And now, before I leave you, a final tip I can give you is to develop a genuine curiosity and passion for understanding how things actually work, not only in programming, but really in the whole world around you. For example, the famous scientist Richard Feynman was repairing radios when he was just a teenager, and Elon Musk made his first computer game when he was 12. And there are many more examples like this, and all of them became geniuses in their fields, in part because of their genuine curiosity on how the world around them works. Alright, and with that being said, let's now go ahead and solve a real problem in the next lecture using this framework that we just learned about. So see you there. Let's now solve together a real problem using the framework that we just learned about and also tools such as Google, Stack Overflow, and MDN. And here is our very simple problem. So let's say that we work for a company that builds a smart home thermometer, and our most recent task is this. So, given an array of temperatures of one day, calculate the temperature amplitude. And keep in mind that sometimes there might be a sensor error. And they give us this array of data. So, what should we do here? How do we solve this problem? And this is actually a pretty simple problem, but it still shows us the fundamental logic of solving problems. Again, using the framework that I just showed you before. And so the 2 most important parts of that is to understand the problem and to breaking up the problem into smaller sub-problems. So let's start by understanding the problem a little bit better by asking some questions. So first of all, they want us to calculate the temperature amplitude. But what actually is that? So we can write that down here. What is temperature amplitude? And the answer to that is that it's the difference between the highest and the lowest temperatures in the array. So answer, difference between highest and lowest temp. And so this is the value that we will have to return from the function. Then we might ask, well, that's quite nice, but how do we actually calculate the highest and the lowest temperature in an array? So let's write that question. So how to compute the max and min temperatures. And finally, they also tell us here that sometimes there might be a sensor error. So what does a sensor error look like? So what's a sensor error and what to do when one occurs? And here the answer is probably to just ignore the error. Now here from our data, we can actually see what an error looks like. So it's this string here which says error, okay? But it's good to have an idea of all of these questions so that we now really understand the problem that we need to solve. And so I think with this here, we do have a pretty good idea. So now, given our understanding of the problem, let's try to break the problem up into smaller sub-problems. So first, we need to make it so that the sensor errors are actually ignored. So as I was saying, the answer to what to do here is to just ignore the sensor errors and simply work with the rest of the data. So how to ignore errors? Then another task is going to be find max value in temperature array. And then another task is to find the minimum value. And another task is going to be to subtract min from max and then return it. So subtracting min from max is of course the amplitude. And so that's what we need to return. And so all of these are simple steps, but it's good to have an idea of how we will solve this problem. And so that's why I wrote down every single step of the way here. So let's start writing a function. So although they don't tell us that we should write a function here, whenever we encounter a task like this, it's a good idea to write a function for it. So let's call this function calc temp amplitude. And so this function will receive an array of temperatures. So let's again just call that temps. And so now we are going to start to work on solving this problem. And let's start here with finding the maximum and the minimum value in this array. We can deal with the errors a little bit later. Now, probably we don't know yet how to do that based on what we just learned, right? I mean, we already have the tools for sure, but this requires a little bit of thinking. And if we don't know yet how to think about this kind of problems, it's a good idea to do some research. And so we will now use Google to research how we can find a maximum value in an array. And so that's what I meant when I said we should do some research and use Google whenever we need to. So what I like to do is to just write JavaScript and then be as descriptive as possible of what I want to achieve. So let's say get max value in array. And so don't be afraid to ask Google this kind of questions whenever you're stuck yourself. Now we get here a couple of replies, basically, but I'm interested in showing you Stack Overflow now. So Stack Overflow is a site of questions and answers, and most of the time someone already had the same question as we have. And so then they ask that question on Stack Overflow, and we can then go there and find a response. And this one here sounds good, right? Find the min-max elements of an array in JavaScript. So let's click on that one. But now here the problem is going to be that at this point, you will not understand most of the solutions. For example, this one here talks about prototypes. This one has like this weird apply and math. And so let's just scroll until one that we can better understand. This one has this weird dots that we will go into later. But here we actually have something that we can understand. So let's focus on this solution here. Okay. And usually the first solution is always the best one, or the first or the second. But in this case, we just scrolled a little bit more so that we can find a solution that we can implement with the tools that we already learned about. So what they're doing here is to start by defining the first element of the array as max. So in the beginning, they basically assume that the maximum value of the array is the first element. And then from here, they loop through the array or over the array. And in each iteration, here they test if the current value is greater than the maximum value. And if it is, then the new maximum here becomes the current element in the array. Okay, does that sound like a good idea? Well, I think that it does. So let's try to implement this ourselves, and then I will try to explain you a little bit better why this is a good solution. So let's create a for loop here. And of course, we don't need to copy the code here from this site. Usually it's best to understand the solutions and then trying to implement it on yourself. So not copying the code exactly from Stack Overflow. So let's start with the counter I. Let's start at 0 as always, even though here they're starting at 1. But never mind, we will just do it like we have always been doing it. So I must stay below the length of the array that we're looping over. And in this case, that's the temperature array, right? So temps dot length and then I plus plus. Okay. And actually, before we do the loop, we need to create that max variable that they have here. So let's do that. Let max equal the temps array. So the very first element. So again, we will start by assuming that the first element of the array is the maximum. And that's because we didn't loop over the array yet at this point. So this is similar to the challenge in the last section where we started out with a sum set to 0. So that was a good starter value. And in this case, a good starting point is simply the first value of the array. And now let's implement that logic here. So if the current value of the array, so that's temps at position I, so the current position is greater than the current maximum value, then the maximum value will become this new value. And that makes sense, right? Because if the current value in the array is greater than the maximum, well, then that value should be the maximum, right? And so that's what we then do here. Okay, and now let's simply log it to the console. And remember that from now on, I will start using the snippet that we defined in the first lecture of the section. So I just type CL, hit return, and then max. Okay, and now just to test this function, let's call it with an array of just some values. So 3, 7, and 4. And so now it's very obvious what the result should be. And so I already saved it, and so probably we now already have the result here in the console, because remember, we still have the live server here running. And so it automatically reloaded the page, and we get the correct result here, which is that 7 is the max value. Let's add something else here, like 23. And now 23 will become the max value. And so the logic here works. So let's get rid of this one, and just to analyze what happens. So in the beginning, before we even start the loop, the max will be the first element of the array. So 3. Okay? Then the loop starts at the first position. So that's 3. So here, then we ask, is 3 greater than 3? No, it's not. So nothing happens. Then in the next iteration of the loop, we are at 7. So then the question is 7 greater than 3, which is the current maximum? And yes, it is. And so now max equals 7. Okay, next iteration of the loop, which is 4. And so the question is 4 greater than 7, which is the current maximum? No, it's not. And so nothing happens, and then we're done. And so the result in the end is that max is equal to 7. All right? Does that make sense? So we solved this problem here, so this sub-problem, where we found the max value. But now we need to do the same for the minimum. And hopefully you can see how that one works, because it's pretty much in the same way. So let's say min, and we will start at the same starting point here. And all we need to do now is to add another line to this loop. So we can do it all in one go. And so now what we're going to say is if the current temperature is less than the minimum, then that should become the new minimum. So min equals the current temperature. And actually, since we're using this here so many times, let's create a variable for that. So const current temperature is equal to temps at position I. And now I'm selecting and then Command D or Control D, 1, 2, 3, 4, and replace all of this with cur temp. Okay, and now just to see again if it works, let's log the minimum as well. And let's add some other value here. And so what can we expect when we save it? Well, the max should be 8 and the min should be 1. So I'm saving, and yes, that works. Next up, we can then tackle the problem of ignoring errors. So what that means is that we do not want to include this, right? Or in other words, this logic here should only run if we actually have a number here. Okay, so basically if the current element is a number, only then it makes sense to make this sort of comparisons. And so we can use something that we learned in the last section, which is the continue keyword. So let's say if the type of the current temperature, so type of current temperature is different from a number, then continue. And remember that continue means that the rest of the iteration will not be executed. So the current iteration will be finished and then it moves on right to the next one. And so in this case, what happens is as soon as the loop reaches this part here, since it's not a number, then none of the logic down here is executed, and then we move on to number 9 right away. Okay, so let's now actually call temp amplitude using our temperatures array. And indeed, we already have here the max and min temperatures. So let's confirm that that's correct. And yes, 7 is the max and -6 is the minimum. Awesome. So that works. Now there's only the easy part left, which is to return the amplitude. So return the max minus the min. Okay, let's get rid of this one here. And here, let's store that result into a variable, or actually amplitude. Okay, and then console log oh, actually there's an error here. This should be called amplitude. Okay, and so 23. So you can probably start to see that this is my favorite number, and so it comes up all the time here. Awesome. We did a great job here in solving this problem. And again, we did it because we first understood it correctly, and then we broke it up into these sub-problems. But now let's suppose that after we're done with our solution, the project manager tells us that the function should actually receive 2 arrays of temperatures and not just 1. But the rest of the function should work just the same. Okay, so, well, let's quickly write that problem down here. So problem 2, function should now receive 2 arrays of temperatures. So let's try to again understand the problem. So we can probably ask the question, when we have two arrays, do we need to implement the same functionality twice? And well, the answer is actually no. So the solution is to just merge the two arrays at the beginning. So just merge two arrays. And now we need to then again break this one up into sub-problems. And in this case, that's just, well, really just one sub-problem, which is how to merge two arrays. Okay, but we can see that this is probably the best thing to do, right? So imagine that we have this same function, but instead of receiving this one here, so just one array, it gets two. Then if we can merge these two arrays into one, then the rest of the logic could stay exactly the same. Okay, and here the problem should actually be just merge two arrays. So that is our sub-problem that we will now solve. So let's now do some more research here. So I think we could actually come up with our own solution here, but really I just want in this lecture to use the tools that we have to solve problems on our own with research. So I want to show you how a developer goes about doing these things. So JavaScript merge two arrays. So we have here the Mozilla developer network that I told you about in the last lecture. And here we also have, again, a Stack Overflow reply. So let's take a look at the Stack Overflow again. So here we see that apparently there is like a concat method. So here we can also see array.concat. So that seems to be the solution. And I remember that previously on that Google results page, there was also something about that. So this first here, so the MDN page is also about the concat method. So let's now actually explore the MDN website a little bit. Okay, and let's make this a bit wider so I can show you how it really looks like. And so MDN looks like this. And once more, it might have changed by the time you're watching this video, but the core functionality will still be there. So there's always a short description about the functionality and then some quick examples. Then here on the left side, we can actually see all the methods about the array. Okay, and that's because we are right now on the page about an array method. So concat is a method of arrays, so similar to push or shift or includes, right? So concat is just one more of these methods. And again, we can see all of the methods here. And as I told you, there are a lot of them. So push, for example, is the one that we already learned about and used. So we can quickly see that. And so indeed, the push method adds 0 or more elements to the end of an array and returns the new length of the array. So this is kind of what we did ourselves previously. And actually we can add multiple elements, which I didn't tell you by the time, but this here works just as well. But anyway, this was just to show you a familiar method. But let's return to concat here. So here is a long description of the method. Here is the exact syntax, which many times looks a bit intimidating. And so I like to actually stick to the examples here. So whenever you need to know how a certain built-in method or function works in JavaScript, you can always just look it up on MDN. This is really the complete but unofficial JavaScript documentation. And in fact, many of the things that I know about JavaScript come here from MDN. So don't be afraid of doing any research that you need on this page or also on Stack Overflow. Anyway, here from this example, we can understand kind of how the concat method works. So we have array 1 and 2, and then on array 1, we can call the concat method and as an argument pass in the second array. And the result will be array 3. And when we log that to the console, we will get A, B, C, D, E, F. And so that's the array 1, A, B, C, and then followed by array 2, essentially, D, E, F. So I will just copy this syntax now and make this smaller again. And I will paste it here, just so we can then use it as a reference. Okay, and now I will get this whole function and not change that one, but instead create a new one. So calc temp amplitude new, and then here we also call the new one and call amplitude new. Okay, amplitude new. And now here we need to change the arguments. So remember that now this new function will receive 2 arrays of temperatures. So I'm just going to call them T1 and T2. Here at the beginning of the function is where we will solve our problem. So this subproblem of merging the 2 arrays. So let's again just put this here just so that we see it as a reference exactly where we need it. So what we want to do is to create a new array, and I will call it temps. And I'm calling it temps because that's the name of the complete array that we already have here in the function. So that used to be the name of the argument of the previous version of this function. And now I can just say the array 1, so array 1, which in our case is T1, dot, and then array number 2, which in our case is T2. And that's it. And now let's just log that to the console very quick. Temps, and we no longer need this. Okay. And here then we need to call this new function with 2 arrays. So let's just create 2 arrays. So 3, 5, and 1. And then another one, 9, 0, and 5. And now let's see. And here we see that it did actually work. So now we get this one array, which includes all the elements basically of these 2 arrays that we passed into calc temp amplitude new. So this function. And we can also see that 9 and 0 are the max and the min, and 9 minus 0 gives 9, which is then this new amplitude new. Awesome. So we solved this problem number 2 here successfully as well now. And yeah, so I hope that now you have a better idea of how to solve problems, and especially how to do research using the tools that I just showed you in this video. So that's Google, Stack Overflow, and also the MDN documentation. And this last one is, in my opinion, actually the most important one. I learned so much from MDN. It's incredible. So now in the future, whenever something is not working in your code, and even during the course, you can always try to figure out the solution on your own, for example, using Google or Stack Overflow. And so that will then be very helpful for your developer journey. So we talked about problem solving, which is a very important skill of any software developer. Now, another extremely important developer skill is debugging, which means to find and fix errors. So let's finish this section by talking about debugging to make you ready for the rest of the course ahead. So first of all, as you might already know, a software bug is a defect or a problem in a computer program. So basically, any unexpected or unintended behavior of a program is called a bug. And the actual term bug was coined in the 1940s when this real bug was causing an error in Harvard's computer. Now, there are many reasons for bugs in programs, but what matters here is that bugs are a completely normal part of software development, because we are humans and humans make mistakes. In fact, every complex application contains bugs, which sometimes go undiscovered for years and can cause security holes or other problems. So really, don't feel bad if you introduce bugs in your own code. We all do it, even the most expert programmers. Now, luckily, not all bugs cause huge security holes. In fact, many bugs are quite small and simple to discover. So let's see a simple example. Remember, in our previous example, the goal was to reverse whatever was passed into the function. So let's say we finished writing the reverse function and call it with this array and get this result. But clearly something is wrong here, right? The returned value looks like scrambled, but not reversed at all. So this means that we must have a bug somewhere in our reverse function. Okay? To fix this, we use a process called debugging, which is essentially finding, fixing, and then preventing bugs. So let's see how that works. So the first step is to actually become aware that there is some kind of bug. Because as I said, in a large application, bugs can actually go undiscovered for years. Now, discovering bugs usually happens during development, using automated testing software, or user reports during production. And bugs that are identified during production are the worst bugs, because it means that they went undiscovered during development and are now affecting real users of our application. So that's why it's really important to identify bugs early, for example, using automated tests. Now, while identifying the bug, sometimes we also need to take into consideration the context in which the bug happened. For example, certain bugs might only happen in a certain browser or only for certain users for some reason. Next, once we know there is a bug, we need to go into our code and find the bug. We need to isolate where exactly it's happening. And we can do that using the developer console that we already know. However, that only works for small bugs in simple code where we have a good idea where the bug might be located. But if the code is more complex and we have no idea where the bug might be, then we need to use a debugger software. And I will show you how that works in the next video, because it's really important for the developer to be able to use a debugger. Anyway, once we know where the bug is located, we can finally fix it. So we can correct the bug. And this is probably the easiest part. So essentially, all we need to do is to replace the existing, so the wrong solution, with a new correct solution that actually works. As a final step, we should then prevent this bug from ever happening again in our codebase. For example, we can search our project for the same bug in similar code, like in a similar function. It's totally possible that we did the same mistake twice in our code. And if that's the case, we must fix the bug everywhere. A more advanced way of preventing bugs is to write tests using testing software. And I might add a bonus section on testing to the course at some point, because this is actually an important part of software development. Okay, and that's it. That's a broad overview of debugging in programming. And we really just scratched the surface here, because you're still at the beginning of the journey. And so this is just an introduction. Anyway, let's now fix some bugs in the next video. Welcome back. So let's now put the debugging process actually into practice. And we're going to start really small and just fix a very simple bug using the console. So let's suppose that in our smart thermometer that we were working on before, we need to do some measurements in a unit called Kelvin, which is the absolute temperature. And the conversion to Kelvin is pretty easy. So all we have to do is to add 273 to the temperature in degrees Celsius. So let's very quickly create a function which will perform this measurement. And this is, of course, all completely fictional. And this function will actually take no arguments at all, because we will get the measurement from a command prompt. So we will basically pretend that the command prompt is like the thermometer sensor. And now let's actually create an object here. So an object for the measurement. So we haven't used objects in some time, and so let's remember that. And let's just set some arbitrary properties here. So the type of measurement is going to be temperature, and the unit will be in Celsius. So basically, we will measure temperature in Celsius, and then we return a converted version. And in there somewhere will be a bug. And now, finally, the value of this measurement will come, as I just mentioned, from a prompt. So let's just say degrees Celsius. And so that will then trigger a prompt. And then let's convert that to Kelvin. So as I said, all we need to do is to take the measurement in degrees Celsius and add 273. So that means measurement dot value. So this property here, where that value in degrees Celsius will be stored, plus 273. And now we can return converted value. And then let's run the function and immediately log the result to the console. So that's measure Kelvin. And now I will give it a save, and it will then ask me for the temperature. So let's say it's 10 degrees Celsius. And so now let's wait for the result in Kelvin. And we get this number, 10,273. And that is not what we expected. We wanted 283, but not this number. So there's got to be a bug somewhere. And so let's find it. And by the way, the first stage of the process was already this one. So A was to identify the bug. Remember? And now we're going to stage B, or stage 2, which is to find the bug. And so since the bug appears in the converted value, which is this one, and this one is derived from this measurement value, let's start by inspecting that measurement value in the console to see if something is wrong there. So console.log measurement.value, give it a save. Oh, and of course now we need to input it again. And so it looks okay actually, right? So it is 10, so that's exactly what we inputted. So it looks kind of normal. I just want to show something now to you, which is that we actually do have things beside console.log. So we also have console.warn and console.error. And with this, we can basically generate warnings and errors in the console. So 10 again, and you see that now this first one looks like a warning, and the second one actually looks like an error. So that's just a matter of formatting, but it's still interesting, I think. But let's take them out. And so, yeah, right now it looks like everything is correct. So let's dig a little bit deeper and take a look at the entire object. And actually, if it was myself, I would have done that immediately, but I want to show you the complete thought process here. So anyway, let's say measurement. So that's the entire object and not just the value. Let's turn off this one as well. Give it a save, 10. And let's open up. And now we actually see the problem. You see, the value is a string. And that's because, as I told you in the last lecture, the prompt function here always returns a string. No matter what we input into that prompt window, it will always just be a string. And so that's why we get this end result here, because as you remember, the plus operator, when it sees a string, it will convert both operands to a string and then concatenate the strings. Just as another curiosity here, there is also another way of showing objects in a console, which is really handy sometimes. So measurement, and so again 10. And so console.table gives us this nicely formatted table. And especially for bigger objects, that can be quite helpful. And let's actually leave that here so that you can see it. So with this, we completed the second phase, and that was to find the bug. And now all we need to do is to fix the bug. So we need to do that right here where it actually occurs. Yeah, so up here. So let's see, fix. And so the solution to this is to convert this string that is returned to a number. So let's use the number function. So we already learned about this one in the last section. And so now we actually expect this to work. And indeed, now we get 283, which is exactly what we were looking for. Great. So this was a very simple example of just using the console in order to hunt down a bug and then fix it. But now let's take it to the next level and learn how to use a debugger in Google Chrome. And let me quickly show that to you with this current function. And for that, we actually need to make this a little bit bigger. And now we go here into sources. So for the first time, we're using the sources tab, and then click here on script.js, which is our current script. Okay, then as we move down, we have our code here. And now here in the debugger, which is basically these two panels here, we can set something called breakpoints. So let's put a breakpoint here in this line of code. So here, and we set a breakpoint by clicking here in this left bar. And so this will set this red point, which means that there is a breakpoint. And now when we reload the page, then the execution will stop exactly at this point. So basically execution will freeze in time and show us exactly what the execution looks like at that moment in time. And that includes all the values of all the defined variables. So let's do that. Let's reload. And so you see, now we are in this function. And now I can click this button here to resume the script execution. And it will then start going over all these lines. But now it can only continue if I input a value here. So that's coming from this prompt. So I put 10 here, hit enter. Then it does all of these lines here. And finally, we reach the line where I set the breakpoint. And so that's this one here marked in green now. And again, at this point, we can then see all the variables. So Kelvin is still undefined because the computation has not yet been done, but we can take a look at measurement here. So the value is 10 as we just inputted. And yeah, this can be very helpful in case that we don't want to mess around with a lot of console.logs or other stuff like that. We can also hover these here. So here we can see the whole object. Here we then can see just the property value. And now we can execute the rest of the function simply by hitting this step button here. So basically this will then go to the next line of code. So now we have Kelvin set at 283 because now the previous line just executed. And here we are in the last line. And so now we can see here return value will be 283. So with this one here, we can execute one line at a time. And for now, just ignore these three buttons here. You can explore them a little bit later. Okay, so we're almost done. Let's just click one more time. And so we're out of the function now. And now processing this next line of code. Let's just continue. And so now we went into some other stuff here, and that's actually coming from the live server. So never mind, we can just close this and now click here on resume script execution. and now we're done. So this is not all super intuitive, I would say. So just experiment around a little bit with these different buttons. Okay, now we just need to get rid of this breakpoint here, otherwise the execution will always stop here in the future. So just click this red dot here again, and then it's gone. And that's how we launch and use the debugger in Google Chrome. Now let's quickly introduce a bigger bug here in our code and then fix it using the debugger. And for that, I'm simply going to go back to this function that we created before. So this one here. And let's call this one here bug. So I will replace all the news with bug. So we have here cog, temp, amplitude, bug. And here we're calling that. And then we call the amplitude back, and here as well, bug. Cancel that one. And actually, let's come here and comment out this piece of code so that it doesn't annoy us all the time. And we can just set the value here manually to 10 now. Okay, this way we preserve the code that we have and also keep it running, or actually keep it working. So here let's just say using a debugger. Then down here we are calling this function, and here let's just change this to something else. Let's say 4. Okay, let's just run this now quickly. And so we see that the output at this point is still correct because we didn't introduce any bug yet. So the max is 9, the min is 1, and therefore the amplitude is 8. But now let's say that we did a mistake. And we might have thought intuitively that the max and min values would be good to have a starting point of 0. I think you can maybe see why that would make sense. So for example, we started the sum at 0 before. So why not start the max and the minimum at 0 too, right? It would have been quite reasonable to think that. And so let's pretend that we did think that, but this will actually introduce a bug because with this will not work. So as you see, now here it says that the minimum value is 0, right? So that's coming from this console.log here, which says now that minimum is 0 and that the amplitude therefore is 9 minus 0, which is 9. So we identified the bug here, okay? Let's again write that identify. And so let's now go back here to Chrome and to the debugger to try to find that bug. And the debugger is actually especially useful inside of a loop. And so that's the situation that we have right now. So we are in a loop. And so let's see here now why the maximum and minimum values are not being correctly set. Or actually it's just the minimum. The maximum is fine, but still we need to analyze both of them. So what I'm going to do here is to set a breakpoint right here, because that's where the maximum and the minimum are being computed. Okay, so let's reload, and right away we get to this point in the execution. So at this point, the temps variable has already been computed, so it's already this complete array. Max and min are at 0, and so now we are doing this. So we see that the current temperature is 3, that the maximum is 0, and so next step will end up here. Or let's actually continue. And indeed, now we see that max is 3. And that makes sense, right? According to the rules that we described earlier. Okay, moving on here. Oh, and we already moved on right to the next loop iteration. And that's because we don't have a breakpoint here. So let's just put another one. And so now we're in the second iteration. And so now I is 1, as you can see here. Okay. So the current temperature is 5, max is 3, and so now the new max should become 5. And yes. Oh, and again we jumped over this one, but let's just keep going. All right. So now the current temperature is 1, max is 5, and so this one will now not get executed. So now we can see this one. Current temperature is 1, which is less than 0, and so nothing is going to happen, right? And so here we actually have the bug itself. So we know intuitively that 1 here is supposed to be our lowest number. But the problem is that 0 is even lower, and so it's impossible for any of these numbers here to be set as the minimum. Again, because the initial value that we set is already lower than any of the values that we have in the array. And so now, by analyzing this one by one in the debugger, we can really understand that is what happens. So again, in this situation is where we would like for this 1 to be set at a minimum, but it's not going to happen because 1 is not less than 0 here. And so now there's not even a point to keep going. Well, we can still do that. So now the current temperature is 4, which is this one. And just one more. So I is 5. So we're in the last iteration. And we see that the maximum is already correct. And now here we can actually also see the loop finishing, because we see that temps.length is 6, and I right now is also 6. So 6 is not less than 6, of course, and so the loop will now finish. So you see, now we jumped over the loop and we are finally here in this next line of code. Let's go to the next one. And the value to return is 9, as we already know, because of our bug in the min. Okay, and that's it. Now we stepped over this entire function logic and saw exactly what happened line by line. And again, we're in the live server here. Let's just remove this and resume the script execution. Okay, great. So I hope that got you an idea of how we can use the debugger. Just wanted to tell you that instead of going through the sources tab here, we can actually also call the debugger right from our code. And all we have to do for that is to write debugger right here. So JavaScript has this debugger statement, and then when the browser sees this debugger, it will automatically open up the debugger tool. So when I give it a save now, you see that we are right at this point. So it's like it put a breakpoint here in this point, and then we can do everything as we just saw before. So let's click here on continue. Or actually, let's just get rid of this here, give it a save, or stop this and reload. And yeah, then we exited that debugger. Now this was of course just a small example, but again, this is an extremely powerful tool that you can now use whenever you run into a problem in the future. So take a moment now to go through the steps again, maybe by yourself, and that will then help you make you a better developer, because debugging really is an intrinsic part of the development process. So I showed you some ideas and some tools to solve problems and to debug your applications. And so now it's your turn to put all of that into practice on your own. And so here is your coding challenge for this section. So given an array of forecasted maximum temperatures, the thermometer that we've been working about throughout this section should display a string with these forecasted temperatures. So for example, if we have this array, which is our first test data here, then the string that it will print should be this. So 3 dots, then 17 degrees Celsius in 1 days. So that's the 17 here. Then again, 3 dots, then 21 degrees Celsius in 2 days. So this 21 is this 21, and then 3 dots, 23 degrees in 3 days. So in 1, 2, and 3 days. And then again, 3 dots. Okay, and here you don't need to use this exact sign if you can't find it on your keyboard. I know it was a bit hard to find for me. So what you should do is to create a function called printForecast, which takes in an array called R, and then logs a string just like this one here to the console. Okay? And call this function for these two test values. And to solve this, you can use the problem-solving framework that we have just been talking about in this section. So try to understand the problem first by asking the right questions, and then break it into sub-problems. And I'm not saying that this is going to be easy. And for me, the main goal is not even that you achieve the result, but really that you start thinking about the problem and that you try as good as possible to break it up into sub-problems. And of course, there are many ways of asking the right questions and of breaking this up into sub-problems. So there's no hard ways of doing this stuff. So just try your best, take all the time that you need, and I will see you here once you're ready. Okay, so let me show you how I would have done it. And let's just close this terminal here, because remember that this live connection actually keeps running without the terminal opened. So let's just grab from up here this here. So as you see, I'm a little bit lazy. I don't like to type so much. So I just keep reusing stuff. So we need to understand the problem first. So let's look at that example string here. And so one part of the problem is definitely that this array here was basically broken up in 3 pieces, and then the separator is these 3 dots. Let's write that here. Array transformed to string separated by 3 dots. Then we can also ask what these numbers here are. So we already know that these here are of course coming from the array. But what is this? So 1 days, 2 days, and 3 days. So what is the X days? And the answer to that is that basically it is the current index of the array plus 1. So it would be weird to say that 17 degrees in 0 days, because this is a forecast. And so this is for the next day, and then in 2 days, and in 3 days. So answer index plus 1. Okay, so I think we understood the problem now, because I think that it's quite simple in this case. So let's now break this up into sub-problems. And I would say that the main problem here will be to transform this array into a string. Because that's essentially what we will have to do. Also, each of these elements here will be transformed to a string with these degrees Celsius. So let's just transform each element to string the Celsius. And I don't even remember where this is, so I'm just copying it here. Then we also need to account for the current day. So string needs to contain day. And again, that is the index plus 1. And finally, we also need to add the 3 dots between elements and start and end of string. So that looks like a lot of work, but actually it is not as hard as it looks from here. So let's start by creating 2 arrays here. So for test data 1 and 2, actually grab all of this in one go. Data 2. All right. And now let's tackle these problems here. Okay. So if the string would always have the same length, so if it would always just be 3 days, then it would be very simple. we could just basically hard code the string, right? We could just do something like data1 at position 0, and then the degrees Celsius, then ... and so on and so forth, right? So here I'm missing these, of course. So we could do this, and there's still some value in first actually trying to write this. So this is how it would look like. Data 0 and 1 and 2. And let's indeed log this to the console. Give it a save. And so actually already the string looks exactly what we had here, right? But of course, this is not the way to go. Because then here in data 2, we have a longer array. And we want to write one function that works for all the arrays. So that print forecast. And so of course we need a more dynamic way of creating this string. But still, as I said, there is some value in having done that, because it will help us figure out how we can arrive at a solution. So print forecast is a function which takes in an array R. And now let's see what we have to do. So if we have an array and we have to do multiple operations on it, we will, as always, use a loop. So let's start with that baseline. So let I equal 0, and this part is now always the same. So I less than R dot length and I plus plus. Okay, but now what are we going to do? So how will we basically transform the array into a string? And there are so many ways in which we could achieve this, and actually in which we could solve this whole problem here, especially if you did some research to arrive at the solution here. But I will just go with a solution using the tools that we already used. So remember what we did when we calculated the average of a number. We started by adding all the values of the array using a loop, right? And we kept adding them to an accumulator variable that was called sum, right? So just to illustrate, that sum started at 0. And let's say we had an array of 2, 3, 4. And so in the first iteration, that sum was then updated to 2. Then in the second iteration, it was updated to 2 plus 3 equals 5. And then in the last iteration, it was updated to 5, which was the current sum, plus 4 equal 9. And so that's how we end up with the sum of all of these values. And now with the string, we can actually do the exact same thing. So here we will also have an accumulator variable essentially, which is going to be called string. So let's string, and instead of starting with 0, we will start with the equivalent of 0, but for strings, which is the empty string. So empty string has nothing. And then in each iteration, we will simply add to that string the current value of the array. So let's do that. String equals the current value of string plus array at the current position. And also let's already add this symbol here. And for that, let's wrap this here into a template literal. And so I'm selecting this, and then I can just hit the template literal, the backtick once, and it will wrap all of that. So then this, and then the degrees Celsius. And now all we need to do is to log that string to the console. So just as was asked, which takes and logs the string to the console. So we could have added that actually as one sub-problem, even though it's a really, really small one. Log string to console. And so let's give it a try now. I'm saving. And nothing happened. Oh, that's because we didn't call the function. So let's print forecast with data1. And here we go. So 17 degrees, 21 degrees, 23 degrees. And that already starts looking like what we have here. So essentially, we already completed the most difficult part, so of transforming the array into a string. And again, this was similar to adding multiple numbers into one bigger number. Here what we did was to add multiple strings to a bigger string that kept growing after each iteration. And if you want to make sure to really understand this, then you can always use the debugger and go through this loop step by step and see this string variable here growing as the loop goes on and on. So we already did this part also, and this part. Now let's tackle this one. So it needs to also contain the day. So what does that look like? So 23 degrees in 3 days. So in 1 day, 2 days, and 3 days. So that's not too hard. So in, and now we already understood that this had to be the current index plus 1. So the current index is I plus 1. So in 1 days. So in the first iteration, it's going to be 0 plus 1, then 1 plus 1, and then 2 plus 1. Give it a save. And that's starting to look really close to what we need in the end. But now we are missing the separator dots. So how do you think we can achieve those? Well, in fact, these dots are simply something that repeat after each of these strings here, right? So we have this value and then dot, dot, dot. So we have the value dot, dot, dot. We just need one more space here to create this nice separation that we have. And so now we're almost done. Okay. So actually this is not correct here because it's missing the in 1 day, in 2 days, and so on and so forth. But let's just compare it here with the original. And so all that is left is these 3 dots at the beginning. And so we can just add them at the end. So we cannot put them here, right? Because then we would have too many dots. So that's a lot of dots. And that's not what we were looking for. So instead, we keep it like this. And then as we log it to the console, we simply add the dots here at the beginning. So dot, 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 plus the string, give it a save. And yes, that's the solution of our problem. Great. We can just improve this here a little bit again by using the plus equal operator. And then get rid of this part. Make it a little bit more short and more efficient maybe. And so, yeah, that's it. That's the result of this coding challenge. And again, you could have done it in so many different ways. But what I really wanted you to achieve was to understand the problem and to break it up into small subproblems. If you did that, well, then my goal with this whole section, I would say, is achieved. So, hope you liked this one, even though it was a little bit more theoretical, but I think it's important to also have a section like this in a big web development course, because soft skills like the ones that I just showed you are also very, very important for your success.